and welcome to the very first episode of the Schrodinger Science Show. Today will be the first lesson of our chemistry unit, and we'll be learning all about atoms, subatomic particles, and isotopes. Let's get started. You might already know that all matter in the world is made up of these tiny building blocks called atoms. So all things you can physically touch, like strawberries and coffee mugs, are composed of countless atoms. Since atoms are so small, you might be surprised to hear that there are still things smaller than them. These are the subatomic particles. Atoms themselves are made up of subatomic particles, and there are three types: protons, neutrons, and electrons. They differ in charge and mass. The concept of charges will be really important later on, but right now let's just focus on mass. Notice how protons and neutrons both have a mass of around 1 unified atomic mass unit, while the mass of electrons is much smaller. This is a zoomed-in diagram of an atom. The protons and neutrons are all clumped together in the center of the atom, and they form something called the nucleus. The electron cloud surrounds the nucleus, and as the name suggests, this is where the electrons are found. Now, the electron cloud makes up most of the atom's volume, and it can be up to 100,000 times larger than the nucleus in diameter. However, because protons and neutrons have a far greater mass than electrons, the nucleus still makes up most of the atom's mass, despite being smaller in terms of volume. Elements are substances that are made up of only one type of atom. Think of it like this. If I had a jar with only blue jelly beans, that would be like an element. But a jar with purple, orange, blue, and yellow jelly beans would be a mixture, not an element. Now let's take this little fella and put him under the super cool science microscope. All elements are defined by the number of protons in each of their atoms. For example, all hydrogen atoms have 1 proton, all helium atoms have 2 protons, and lithium atoms have 3, and so on. This means that by definition, all atoms of the same element must have the same number of protons. Even though the number of protons in an element always stays the same can't be said for neutrons. Atoms of the same element with different numbers of neutrons are called isotopes. As you can see, an element can have lots of different isotopes. Isotopes have varying masses, and their properties are usually similar but not always identical. Some isotopes are naturally occurring while others are not. Isotope notation is the way in which scientists define isotopes in writing. Before we get to that, here's some terminology that's important to know. Mass number is the number of protons plus the number of neutrons. Atomic number is just the number of protons, and the chemical symbol is an abbreviation of the element's name. This first form of isotope notation is called standard nuclear notation, where you'll write both the isotope's mass number and the atomic number, followed by the chemical symbol. The second form is called hyphen notation, where you write the chemical symbol followed by a hyphen and then the mass number. Thank you so much for watching our video, and bye!